Hi, welcome back to AQA Certificate Further Mathematics GCSE. This is Chapter 9.1, Multiplying Matrices. It's a grade A video. Before I start, I should say that because the previous chapters are a bit boring, I want to take a break and start something a bit more difficult. So this is Chapter 9 instead of Chapter 2. So I'm going to fill in the gaps after I finish this chapter. So stay tuned for that, and let's get started. So there are three things that you need to know about matrices. You need to know how to add, subtract, and multiply matrices, and that sounds a bit difficult because you don't know what matrices are, and I'm going to talk about that later. The second one will be there are three types of multiplication to learn, so there are actually 5 things to learn. Joy. Or 6 rather, because actually there are 4 types of multiplication, so yeah, I'm going to talk through them. Then the third point will be knowing that not every matrix can be multiplied to another matrix, and that I'll explain later again. So yeah, let's start the examples. So before we start the chapter, let's talk about what is a matrix. A matrix is basically a bracket with numbers inside it. This is called a 2x2 matrix because it's height 2 and width 2. But what about if it's like say 1x2 or 2x1? Will that make a difference? And the answer is that will indeed make a difference. But how do we determine the name of the matrix? We use a general rule. Height by width is the name. So for this, the height is equal to 2 and the width is 2, so it's a 2x2. If it's just these two, then it would be a 1x2. So that is the name of matrix and what it means. Now look into the matrix, you'll find 4 numbers. The number of numbers or number of terms inside a matrix is given by the size of the matrix or the name of the matrix, and numbers within don't interact with each other in any way. So you won't suddenly see, 5 and 2 together is 10. That wouldn't happen, sorry. And 4 and -3 never make 1, because they never have any relationship with each other, unless you use it in a calculation, that is. And yeah, that would be a 2x2 matrix, and I'm going to explain other forms of matrix. So after 2x2 comes a basic 1x2, and we have seen this somewhere halfway. I'll give you 5 seconds to think about it, and I'm going to add the thing that makes this familiar. And I think it's time to add this. This is a comma, by the way. And yeah, that would be a coordinate, right? But I'll talk about that later. You really shouldn't think of matrix as a coordinate, because that doesn't work. This is a 1x2, and you shouldn't use this to be thinking of a coordinate. Other than this, there is another matrix, which is its reverse, rather likely. I would say it's a reverse, but it's definitely not the kind of reverse that you guys might refer to. This is a 2x1. My reverse means these two, and it's basically a straight one and a wide one. This one we'll use as coordinates later on, but remember, whenever you use coordinate, don't use it as a 1x2, use it as a 2x1. And this is also called the factor if you're not sure. Factor stores coordinates, so we use this kind of matrix instead of the white one. So you've got a friend who have a cabinet or drawer, whatever, and it has a grid pattern on it. So it contains -2 number of sugar, 2 sugar, -4 amount of sugar, and 5 sugar. I refer to that because that is a bit funny. That is not, so rather yeah, that is one thing. Classify these 4 as separate so that you don't mix them up. My good way is to think of it as a drawer, and you've got essentially let's see, a thing with 4 separations. So yeah, there we go. Then each holds a thing of a number, so you can just do the calculation in each box, and that works. So I say, yeah, let's keep to the story. And he says, I don't want this drawer anymore or cabinet anymore, so I'm going to give this to you. And now you have another cupboard, and this is your original one, this is the new one, and you decided to just transfer everything in one cabinet to another to the original one with the same place. So that would be 5 plus a -2, which is 5 minus 2. 2 plus a 2 equals a 4. A 4 minus a 4 is a 0, and -3 plus a 5, which will equate to wait a minute, there, this is the calculation part, and that would be the answer. So that is as simple as that. Just think of it as a drawer or something like that. Yeah, that would do a addition. And so yeah, proceed to, I guess, multiplication. Thinking about it, I'm going to rephrase this thing, and I'm going to say, so he gave you a box, right? There are 4 holding cells. Sounds like a jail, never mind. There are 4 box that you can use in it, and you basically transfer or add or subtract anything within that single box on each matrix, and you can actually see easily. You can just separate them with lines, and there will be 4 grid like patterns, and that works with basically any matrix, and it's really useful for addition. But to be fair, I never see a further math paper using addition of matrix, so yeah, you don't really need to worry about this thing. So yeah, let's proceed to multiplication. Since addition is so simple, I guess I can explain this a bit easier now. And what you just need to do is, because there are 3 of this cabinet, you have 3 times the contents. That is simple, right? Just do this and you get the answer. Sorry. Yeah, the 3 get 3 cabinet, and you get 3 times the content. So yeah, that's multiplication outside bracket. I mean a matrix. A matrix by matrix multiplication is the most important because it has the highest chance of being chosen by examiners for exam topic. And in question 3A, we're going to do a 1 by 2 times a 2 by 1 matrix. And just looking at it, we'll see, wait, as we have proven last time, if we treat them as drawers, then we have to multiply. Wait, that doesn't work, does it? Yes, I have to admit that the drawer method doesn't work up high in matrices times matrices, but we can still use the concept to understand how come something works like that. So yeah, let me prepare that and I will be back. So yeah, I'm back. And so let's say I've got told that I have to move, and I've got a new cupboard CD, and my old cupboard AB is still there. So I was thinking, how should I move them? Well, when you look up to AB, A is on the left hand side, B is on the right hand side. When you turn 90 degrees around, you'll find that C is on the left hand side, D is on the right hand side. Well, isn't that convenient? Just move things around and turn them clockwise, everything, and just multiply them. Yeah, that is equal to AC plus BD, because A, the left hand side term, and the left hand side term, right hand side term with the right hand side term, and you just add them together to form only one term. This is unique to 1 by 2 times 2 by 1 matrix. It only gives one term in return for two, like from, let's say, 4 terms. So for 2 by 2 times 2 by 1 matrix, I think the same thing still applies, does it? Go back to that diagram. I again have to move, but now I've only got 2 drawer space. What should I do? Well, I will do this one row by one row, just do the same thing over and over again. And that would take 2 times, but it would move everything, right? So it's the thing is the same with 1 by 2 times 2 by 1. It's just you have to do it twice, and with that you'll get 2 terms, AW plus BX over, well, not over, never say over again, because matrices are not fractions, so I can't say over. Okay, cool down, chill out. And it's AW plus BX and CW plus DX as the 2 terms inside this 2 by 1 matrix. Remember, if there's a 4 times there's a 2 by 2 times a 2 by 1, it will result in a 2 by 1 matrix. Just have to remember this, and yeah, proceed to, I think it's 2 by 2 times 2 by 2. So now we're on 2 by 2 matrices, and tell you what, the cabinet won't work on this, so I hope you now understand how you should manage those rows and columns, because now things are going to get real. We can't always stay stuck at the cupboard calculation, can we? But I can change this to something more, say, forgiving. Alright, it's a bit easier to understand this, and proven that given that if you did understand the cabinet, you should be able to do this. And now, first of all, the first step would be to divide the matrix into such fashion. The front matrix should be divided into 2 let me see, it's a 1 by 2 matrix, so there are 2 1 by 2 matrix here, say, it's not really a matrix, but yeah, it's you know what I mean. It's 1 by 2, and the back one you divide it into a 2 by 1. So that would be the first step you would do, and I would highly encourage you to label them into different columns and rows, because that if you do that, you won't mess things up and be all I don't know what to do, let's say. So what do you do now? First, you will have to do combinations of these two things. Each you need to do for each combination, and I tell you there are 4 combinations. Try and work them out. Pause the video now and label them row 1 or 2 times column 3 or 4, and see if you match the thing that I've got. So yeah, you can pause it now. Okay, time's up, and that is what you should have got. Do row 1 multiplied by column 3, row 2 multiplied by column 3, row 1 multiplied by column 4, and row 2 multiplied by column 4. That is the 4 things that you have to do to calculate the 4 values that you'll get in the final matrix. And spoilers, a 2 by 2 times a 2 by 2 will give a 2 by 2. Yeah, obviously. So now, if you have paused the video and done the calculation yourself, you would probably get this. AW plus BY is one term, CW plus DY is one term, AX plus BZ is one term, and CX plus DZ Z is another term. Now, the trouble comes. Where does the matrix go? We've said that it's a 2 by 2, but which goes where? Well, there's a simpler way to talk about that, given the diagram, and I need to make space for it, so I'm going to remove this. So if you want to copy it down, and you can always go back to you can go back in time, because it's a video of course, so I'm gonna remove that and instead put my carefully drawn diagram. It's a bit weird, but you know its purpose. So for a 2 by 2 matrix, there are 4 corners, and there are indeed 4 corners labeled in squares, or this is not a square. And so what determines the value is the column number and the row number. And for this value, it's made from off the screen I can read row 1 times column 3. And if you overlap these two matrices, you'll find that column 1 is the top horizontal, which is these two, and 3 is the left one, which is this one. So we know that AW plus BY goes to the left, top left corner. So this is what this grid is doing for us. It's determining which corner we are going to put the values into. So now do AX plus BZ for yourself, and I'm not going to explain, and yeah, pause the video and do it yourself if you want to, or I will proceed now. So AX plus BZ is we know row 1 times column 4, so it must be row 1 and row 4. These two overlaps here, and therefore goes AX plus BZ right here. So now comes the trouble point where you don't know which goes where and what is what, and you feel like you're going to lose the plot. Do not, because you can do one thing. Break them into brackets so you know which term goes which term is which term, and you aren't going to accidentally add them or subtract them. Okay, so back to the point, and you should now be able to figure out that this goes here and this goes here. There. Okay, so let me finish it. There. So this is how you do a 2x2 multiplication of matrices, and that works for any value, obviously. So yeah, if you want to copy out this question for your reference, you're totally welcome to. And yeah, I think I am going to do another example question on some of the forbidden multiplications. So this is a 1x2 times a 1x2 matrix AB times CD. I have said that this is forbidden. What would that mean? I can give you a few minutes to think about it. And now I'm back. So basically, what is the reason? The reason is that because this two terms for the matrix in the front, you have to look at this width of the matrix, which is 2 here, and for the second one you have to look at the height, which is 1, and they aren't equal, are they? And the reason that this is forbidden is because these two terms must be equal to perform any multiplication, and that is true for any matrix. And there are exceptions, like think it's 2 by 1 times 1 by 2, which is the straight one times the horizontal one. That wouldn't work as well in that order. I'm not sure about that, how to explain that, but that is definitely not possible. Yeah, let's draw that out. Yeah, like that, something. Yeah, so that is forbidden examples for matrix. So now I'm going to include the things that we have learned before and apply it to matrices. So now it is to adapt the skill of manipulating matrices and use that to solve questions. And here we have two unknowns, A and B. So I've got this set of equation, and can you figure out what is A and B? What you need to do is to make equations out of these values, and it sounds complicated, but it's actually really simple. If you still remember this, wrong thing, sorry. If you still remember this separation, like last question, then you will know the four combination is, the first one will be 2 plus A, the second one would be 5A, then it's down to 2B plus 4, and finally 20. So what are we interested at is the values of the unknown, and what we know about them is that after this transformation, the four things will equate to this matrix, and correspondingly I can say that 2A plus A equals 4 and 5A equals 10. So these two both makes A equals 2 if you're quick at doing linear equation. And which by the way you should be like if you are doing chapter 9. And for this one it would be equal to 10 because it's labeled on the matrix. And finally 20 equals 20, obviously that is don't need to explain that, do I? Because b times 0 equals 0 apparently, so 0 plus 20 equals 20 obviously. And so the only clue for b is this one, so what we need to do is just do linear, and there you got b equals 3. So now we have solved it, and we can just put the numbers back in. Guess I need to do a copy and paste and put the numbers in. Just do that. Yeah, 1, 2, 3, 4 is exactly what I've used in the matrix. So yeah, that is how you solve equations using matrices. So my tips for doing matrices are to use my square diagram, and you can actually color code them so that it's a bit easier to manage. And for the corners you can do a mixture of those two colors if you want to, but it's difficult to do it on the computer, so I'm not going to fill them. Just guess it yourself. So for every top row it's going to be the top ones, the bottom row will be the bottom ones, the left side will be the left side, right side will be the right side. So yeah, that is the square diagram and colored version. And for B, just remember how to turn the 90 degree from this to this, because if you don't do the turn 90 degree, it's not going to work, simply because that is entirely how matrices is required to be solved. So if you don't turn the 90 degree, then it's going to be, let's say, not solvable. So yeah, let's proceed to some of the questions that I'm going to give. So here are 7 questions for you to complete, and if I didn't tell you, you can actually assign a matrix to a variable. So yeah, that is quite simple to describe all the questions using just symbols. This is just for myself, not for you guys, so you guys have to actually write out the questions yourself. And for question 7, it's one of the ways of solving simultaneous equations. So this question is actually made using a simultaneous equation, so you can definitely find x and y. The thing is, do you know how to? And so in the count of 5, you will get the answer on screen. So 5, 4, 3, 2, 1. And here are the answers. Just so you know, I actually decided to hide a deliberate mistake inside this. So if you can find that and spot that, leave me a comment, tell me where it is, and that would be good. And yeah, I will see you next time. If I well, no, never mind, I'm going to see you next time. Thank you for watching. If you learned something, leave me a like, and remember to comment for that mistake. See you next time.